Okay, guys, it's smarthelping.com here. It's 12:30 on June 24th. I've got a little break in the action. I do financial consulting, work for all kinds of clients around the world, and I try to build template models on the side for fun and for money, obviously. You see smarthelping.com sells these. So today is going to be, and this is going to be really, I don't even know if it'll be possible, but I'm going to try to build a model for optimizing loan paybacks, and these are going to be only P&I loans, such as a house mortgage, traditional house mortgage, or a car loan. It's not really going to worry about credit card debt. It's just too complicated to try to have all those different things involved. Um, I mean, maybe if I get into the logic and it turns out that it wasn't too difficult, we can add credit card debt as well. But for now, it's just going to be up to 12 possible P&I loans. Now I'm going to do something different. I'm going to walk you through myself building this because, well, it's a boring day. It's very rare that I have time available just to, talk and do this and whatever else. Um, so, so we're going to do this. I'm going to try and talk you through from start to finish. I don't know if it's actually going to be possible. I've just populated 12 amortization schedules. I don't know if it's going to be easier to do it with a full schedule, dynamic schedules here or not, but whatever. I we'll see when we get into it. This is how I'm just going to walk you through my process of how I go about doing this live. So, okay, so we want to optimize. Basically, you've got these loans. You know you got to pay the principal and interest back on them all at the same time. Um, the bank is just not going to let you not make payments back. Now, what will vary is if you have the option to pay more principal than what is due. And in that case, how do you optimize how much to put on what loans? Now, it's going to be obviously the highest interest rate, a mixture between what's the highest interest rate and what's the highest balance. And the idea is based on a fixed amount of money that you have on top of the standard debt service. What's the optimal way to allocate that over time so that you pay back the loans in the fastest amount of time with the least amount of interest paid? Because the key is obviously the principles never change. The principle is what it is, in the loans that we're modeling. But what will change is the interest you pay, and that will be based on, because if you can reduce the principal quicker, then the interest can go down. Now, there's obviously in with any model, there's a million different cases that you could say, well, it doesn't work in this, that, or that. Well, that's true. There's obviously a million different types of loans, but what we're going to focus on here is strictly P&I loans where you pay a monthly principal and interest, and you have the option to pay back more principal if you want. That covers probably the majority of people that are in this situation. So that's what I'm trying to build for. So the key is if you have, let's say, 500 extra dollars a month, how and when should you allocate that to your um, your loan payments? Okay, so and I've seen a couple of these in the past, and they are very difficult to make user friendly and still do what you want them to do, and we'll probably see why in this process. So we have the 12 loans. So let's just, we'll have the high level details. So loan 1 through 12. This will be this will be input. Loan assumptions. And I'm trying to think. See, this is already going to be getting complicated because the question is, do we also need to show this happening over time? Because, well, what we're going to assume is your current loan amount. So it doesn't matter what it was originally. What's the current amount as of today? So you put in the current loan amount due before your next payment's due. You enter that there, so we'll just enter some arbitrary numbers. We'll say you got a 20,000, a 5,000, 150,000. Now this might be kind of tie in with another model I've done, equipment rental, because with that you would have possibly multiple loans that you're trying to pay back. It could be just also um, a normal business that has like loans for different things and different amounts and different interest rates. Uh, Whatever the case may be, if you don't have to use this many, you can just put zeros in here like this. And if you zoom out here a little bit, loan assumptions. Okay, so we've got our loans, description, name, and a lot of modeling is formatting as well as just making sure everything's clear. Okay, so we've got the loan description here, which everything in this color is going to be editable. Just cells in this shade. So we've got all our loan names here. We've got the current balance of each loan. And oh my God, I'm already thinking about how this is going to be really difficult. I don't even know if we'll be able to do it. We'll have the current loan balance of each loan. We're going to assume it's all a fixed rate. So interest rate, or yes, interest rate. We're going to assume they're all 12 payments a year. Well, you can change it. We'll see if the logic will actually care if it's different or not. So this will be interest rates. Let's just say, so let's say the lower one, let's say you've got this at 10%, 5, 15, 3, 2. And it's going to be interesting to test out because it's going to be important to make sure that the model will work, assuming these could be anything. So we don't want to always assume that the highest interest rate is going to be with the highest amount. Well, for now, let's just put this down to 3. Put this up. Yeah, that's fine. So payments per year. Now this is something we probably can't assume, but we'll see if the logic actually takes that into account. All right, so you got the balance. Do we have everything we need? The balance, the term. I still don't know how this is even going to work. I'll have to set these cells all equal to the loan assumptions. We don't need this. Actually, yeah, we could just say current date, current month, and just put the first day of the first month. So let's just say it's next month, 2018. Formatting the date here. So that'll be an input. Actually, I'll just do a short date so you can easily see what you got to type in. So it's just going to be as of today, here's all the balances, here's my interest rates, here's my payments per year. And I think that's it. Now, actually, what we could do, well, we want this to drive 1 through 12. So let's see if there's an easy way equals that. It's just going to be go so C4, 5. Oh, I can't change it till after. So we'll have to put this in. Wondering. Let's do this instead. So let's make this automatic. So we'll put the name, and it'll be, you can pick from the list of loans that are there. And based on that, it's going to return all these values dynamically. So now I don't have to set equals to everything else. So these could be picked. So pick your loan, and then it's just going to do, so this is going to be a Vlookup loan 2, and I want the amount, so I'm going to go 1, 2, 2 false. The term, oh, the term, I haven't put that in, so what's the total term? Now let's see, actually, so to make this make sense, we'll have to do remaining years. Oh, this is going to be tough. Let's just say, I still don't even know how we're going to optimize to get the best allocation. That's going to be hard. So let's just say this has got 25, 25, 2 years, 1 year, 3. Now, hmm, yeah, because basically you're saying you're starting the loan right now today. The thing is, if it's in between a year, what do we do? Because here's the thing, if you've already done stuff in the past, we want this to be the current balance. We don't want this to be the balance it was originally, and then try to figure out where we are in the life of it, because you might have paid more or less in the past. So it kind of makes a lot of sense to start with this current balance. So we got our current balance for the loan. The payments, if we say there's, say, X years remaining. Now let's do a little experiment here. So let's just look at the first one. Let's assume it's a 30-year term. At this interest rate, I just want to test something out. Payments per year. And we're just going to say that's today. Will that also affect how we do this? So this is saying your payment is $17.55 a month. Now let's say the balance is, let's say it's 2 years into it, so year 20, month 24, balance is 197. $552, and then there's only 28 years left. Let's see if it's still the same $17.55 payment. 28, slightly different. Now the question is why? Is it because it wasn't exactly, let's see, after 24, let's try this one. In 2 years, 1755.14, is that what it was before? Yep. Okay. Perfect. So that means, so this should make sense, holding all else equal. If you put your remaining financed amount, or remaining term, and the amount left, your payment should still be the same, and it's going to finish you'll theoretically finish on the same months. Now the question is, what if we add principal to this? Let's say, and this might be, we might have to adjust how this logic is working too. So let's say we're down here, let's say we put, I don't know, 5,000. Does it change when it's paid off? Because right now it's paid off, well, it should be paid off month 336. But if we put let's say we put 15,000 here, does it still go out and make it last longer? Yes, it's just reducing the payment amount. So you can see your payment amount goes from 1775 to 1638. Rather than just paying the same, yep. Okay, so first snag, I've got to delete all of these because this amortization schedule's got to be adjusted to work so that if you pay more, it makes it be paid off sooner. Oh, this is a tough model. I've known about the. I've been thinking about trying to do this for months now, and I never tried because I knew it was going to take forever. So I got to sit here and think. So the question is, get rid of this. So we can still put our loan. This will still be a drop down. Here, at least we'll set this up because this won't change. So you pick the loan, and then it does Vlookup that, and the term is, or the balance is that, and then the term is at the end. It's in F. B, C, D, E, F, so 5. Interest rate is in D. So we'll go D here. B, C, D, so 3. And payments per year is in E. For, and then this will always just reference this no matter what, first date or the current date. Okay, so we got that at least. You can pick whatever loan and it'll give you all the dynamic information so that way you can be sure the right loan's representing the right stuff. All right, so we're back to this issue. We got a loan here. We want to make sure, the whole point of this is we want to make it so that, let's say you have extra monthly cash put to debt. So let's just say every month, man, this is going to be hard. We'll just say every month come on. You're putting in an extra, let's say $500. So every month you go extra 500 bucks. Where do you allocate that based on this scenario so that you pay off the loans the fastest? And theoretically, the fastest should mean the least amount of interest, but I'm not actually sure about that. So we're going to see, we really want to see how do we pay the least amount back, because that should get us to the number we want, or the basically the logic that we're trying to solve for. So the least amount of interest should be also the fastest, but I don't know. So we've got $500. Man, if I could figure this out, man, this is gonna be an awesome model, but I don't know. Now we basically need to look at. So these all have different terms. Let's just put a couple. So let me make a copy of this. Oh, we'll just do a couple here. So this will be 2, because I need to see what different things at least. So this will be loan 3, and this will be loan 2. So it's saying 50,000 left, 20 years remaining, 1.5 million left, 5 years remaining. Now with this extreme 1.5 million left with 5 years, this is probably going to help us determine the logic that actually needs to be done to make this work. Okay, so we got our 3 loans here, all different terms. So we have an extra $500. What loan gets what? so that the least amount of interest is paid. Well, we have to kind of understand interest to know this. I'm going to just make an assumption. The interest, the loan with the most interest left is going to need to get that payment, and then once it's paid off, you shuffle to the next highest. So let's see if that logic makes sense, and based on that, we need to rank these. And now this is, so interest remaining. And there's no dynamic way to do this. We're going to have to assume whatever this row is always going to be in tab 1. And oh no, you know what we can do? We can use some cool Excel stuff, formatting, so we can just put 1, 2, 3, 4. Now the thing with this is you're going to actually have to make sure you don't change this to something else because it's going to reference a tab name indirectly. So custom, we'll do loan. So it still recognizes it as a number, but it says loan 1 through 12 on it there. So now I can just do an indirect. Indirect, oh geez. I'm gonna have to go to my indirect code because I don't remember. Indirect's always a tough one. I never really harnessed that. 1 second. I'm gonna pause the video because I can't go through my desktop with this on. Okay, so I've just pulled the code from something else here, so we should be able to just do some indirect. This is going to say 1. And the cell we want is, we want E3. Why is this messed up? Ah, because now this needs to be a 1. And then we need to format it the same way as the loan assumption. So loan, to space, and then the number. Just do that to each of these. 2, 3. Perfect. All right, so we want E3 on every one of them. So let's do indirect and explanation. We want E3, E3 only. Now that should do it. Let's see. Perfect. Simple as that. Now we can just drag this down and oh my goodness. Clear all. Now these obviously I haven't made these tabs yet, but I will, and it will then work just fine. So here's the remaining interest per loan. So what we want to do is rank these from highest to lowest and then return the loan number. So let's rank here. So we'll do rank. Now the question is, how do we dynamically, let's put this down here. Helper. Now the question is if there's the same amount of interest, what gets picked? Well, in that case, you're going to have an error. And that's just, you're going to have to just pick or adjust something, maybe make one of these interest rates 5.0000001, so it's like an immaterial amount, but it just makes the remaining interest slightly different so that it can rank one above the other. Not a hard workaround and not really a material effect. So let's just go here. So this is going to be so we can now, and actually, so we don't need these helpers at all. We can just put the remaining interest on this side. That works just fine. Give ourselves some space. Okay. So we've got remaining interest here. We want to rank those. So interest ranked. Well, let's see. Let's just try a function here, rank. What does this do? The function is available for values and earlier returns a rank of a number in a list of numbers, its size relative to other values. What's this do? Returns a rank of a number in a list of numbers, its relative to other values in the list. If more than one value has the same rank, the top rank of that set is returned. Okay, they just talked about exactly what I was saying. Let's try and rank this here. Now, what's the reference? Dang it. Okay, functions. What is rank mean? All right, I'm gonna have to look at the syntax here. Rank function. Now in Google Sheets, I know this can be done easier. Rank EQ is what we're using. All right, so reference is an array of values. Oh, so we actually have to choose rank. So here's what we got to do. We got to choose the rank this number within this set of values. And then our order is probably going to define least to great descending or ascending. So we want to say, doesn't even matter as long as our order will do ascending. So that was 1. We only need 12. Okay. So let's just, now that, I don't want to do this because we're still going to have to adjust the way this works. So let's just make our rank function the first 3 just so we don't have to redo all those. So we'll do first 6. So and we'll keep these the same. So there you go, 3, 1, and 2. So now that we have that information, we know this is going directly referencing, so we could say loan 1 is loan number. So here's the loan number, and here's the rank. And then we can just look that up. So actually, let's put this back over here. And we don't need that. We can actually just look up, I think, let's see. So loan 1, 2, 3, 4, 5, 6. So the highest amount of interest remaining is loan 1 at 396. And then, oh, that doesn't make sense. Why is it ranking? Oh, the rank. Okay, so we got the rank 3, 2, 1, and 2. We actually now need to say The highest is number 1. So let's get rid of this. All right, so we got interest ranked. Loan 1 is 3rd position. Oh, we have to hard code in. So what's the first highest, second highest, third highest? And now we just do this. This Vlookup. Oh, what happened? Oh, F4, G4. C, D, E, F. Okay, so loan number, because we know these are in the same position, so we got, here's the rank, here's the loan number, so now we can put them in order highest to lowest interest. See if this makes sense. So we got loan 2. This can't change. So we got this, and now we do our VLOOKUP on the loan number. So 1, 2, 3, 4, 5, 6, and we could look up all this information now if we wanted. So there's our highest. So you can see the fun of this. You really got to think through. Now, is that right? Oh, it did lowest to highest because we did ascending order. Let's do descending order and see if we get the right thing. There we go. So we're ranking highest interest to lowest, and we got the loan number attached here. Now this will, no matter how many loans we change, all we'll have to do is just drag these down, and this will automatically tell me the rank of each loan from top to bottom. Then we've got, so highest to lowest interest, top 1, 2, 3, and this is going to be loan, so we can format this. Number, okay, interest owed. And there's our rank. So we know what loan owes the most and the least. So the question is now, how do we go over to loan 1 and say, okay, apply $500 a month or a payment period, and then don't update don't make this thing keep going out so it automatically always finishes in this term. Adjust the term or reduce or just pay off the principal assuming the payment stays the same, which is whatever the payment is. So let's do the payments. So the payments would be, we can look up the first payment. So no, this is payment 1. So the initial payment amount should be, well, it should always be here, but it might be different if you make an extra payment on the very first month. So assuming you know this, then what's our payment? Let's do PMT. Rate, number of payments, 28 left times 12. Oh, I think we have to do a rate divided, yeah, a rate divided by 12 too, I think. Present value, that, and let's see. Oh, we got to do a negative to this. Okay, so there is our theoretical payment. right now, assuming we do nothing different and just keep paying all the principals. So we need to reference this in each one. So you got that in G4. So G4. This is why I don't want to make too many before I actually have the full structure of what is going to have to be on each amortization schedule. Okay, so now we can reference G5 here. So we could say now we want to sum G5 as well, just to see. Hey, look at, oh, G5, G5. So there you go. Current payment. Paying 1,700 a month here and here and here. Now the question is, you've got an extra 500. We're already assuming we have to apply that to the highest interest remaining balance. So that's kind of, we're going to use this ranking system as our default on how we're optimizing. I'm not sure if that actually makes sense. We'll see what the results look like, but we're going to assume we want to pay off this first. So put as much as you can in here. When that's paid off, you can pay the rest. Now, if this loan lasts longer than all the rest, then it's just going to say, well, it's optimal that you pay this off, put your extra towards this because it's just got so much more interest. That's the assumption we're doing. All right, so there are 500. Now the question is, how do we make that happen on here? We're going to have to adjust the formula. So we actually want the payment to be, let's see. So this is always going to be, you're always assuming this is going to be, well, let's just say the month extra payments applied. So we'll make it a little bit dynamic here. And actually we can put that on the global here. And we'll just do, this will be a dynamic data validation. We'll do, this should have all the dates that are possible. We'll do up to how many? I mean, probably won't be going down that far. So that should be enough. And this is when you start doing this planning. And that's got to be a date. So let's assume we're going to start, all these loans are, we're saying this is the current state as of this date, and this month is when we're going to start applying our extra monthly cash amount. Okay, in that case, we go to, let's see, how can we make this dynamic? We say number, so the first rank is always going to have this first date. We can assume that. That's not, that's kind of logic there. So August of 18, start extra payment month. So August of 18 is when we start, and so then we could say, now we don't know technically if loan 1, 2, or 3 is the highest. So let's assume this is saying loan 1 is the highest because, well, this interest rate in the years remaining. Let's say this years remaining goes down to 3. Now our rank changes. Now loan 3 is the first. So loan 3 So we have to make it dynamic and say, where do we start? And I gotta go to the bathroom. I'll be right back. Alrighty. Are we back? Yeah. Okay, so how do we figure out how to make this dynamic for what is applied to what and when? So I think we have to know just to start what loan is actually the highest. So we could do highest loan is if the loan number equals rank 1, then first, otherwise blank. And then we do if this equals first, then pick this date, otherwise blank. And start. So there you go, is that. And let's just put all this into G4. Now I can see why I shouldn't duplicate all these until I'm actually done. Okay, so these are both blank, so okay, that's not going to be the start. We're just going to keep paying this like normal. Loan 2, that's not the start. We're just going to keep paying this like normal. Loan 3 up first, and here's the start. So we need to start putting our extra amount of $500 here somewhere. So let's say plus 500. Now see, this is just automatically adjusting the payments below to match these terms. I don't want that. I want the payment to actually stay the same. But I don't know if that's going to create a circular reference because of how we're dynamically pulling the total interest paid. This is where things get hairy. So how do we solve this? How are we going to solve this? Well, this has to be different. And we're going to have to unhide some of this. So this is doing the payment number, and this is referencing the amount of payments left to figure out what the payment amount should be. So here's what I'm going to do. Instead of doing it that way, because this automatically makes it so this always is reached. It'll always be this long and this many months. Let's do this. Let's do the first payment is going to be this plus if this equals first, then this, otherwise 0. Yep, yep, yep. There is the issue. It's a circular reference with the interest, and I knew that was going to happen because you can't check the interest and also apply the result of that to the payment amount. And this is where you run into a whole bunch of issues with amortization schedules. So what we have to do is, let's see if we can do this. plus, if I don't think it'll work, let's just do plus this, and we'll know. Oh, wait. Now that worked. But can I do this? If this equals first, then this, otherwise 0, and then can I reference this? Now here, yep, circular reference. Crap. Oh, shoot. So we have a problem. How do we know beforehand what the total interest is going to be paid? And then how do we adjust the future payments so that the future interest does not care what the payment is? Because as you make these extra payments, the amount of interest changes. Now this is, yeah, I mean, this is getting insane. I mean, if we make an extra schedule, so let's say we copy this, copy number 1, and in this schedule we actually do, see, the key is we have to know who to apply first. And to know that, yeah, this is where things get messed. This is why I didn't want to do this, because this is messed up. So I have to know, so I've got my rank here, so it says pay off loan 3 first, then 1, then 2. But we need to allocate an extra $500. Now, if you allocate an extra $500, it's going to change the total interest owed. This is not static. So how do we make this dynamic? Because this is where that interest is pulling from. Oh. Let's see if we can do a meta schedule. So let's say if this equals first, then do this plus this. Now that should work fine. Okay, yep. And then, so we know actual payment. This might work. So our actual payment, let's lock that and that. It's going to say this is our payment rather than this. So if this is what we're paying, we'd take our interests. Let's try and do this. Interest will be the same. Based on the balance. So does this go lower? Yeah. I can't tell because the loan is so small. We can do this though. Does this equal this? Is this less than this? Nope. Must equal it. True. Oh, because we're not adjusting our balance. So we need a new starting balance too. So let's go, that's payment, interest, principal, balance. So here's this. Now this is all technically we should need is just these. So for interest, we do that. Let's go over one, but now instead of referencing this balance, we'll reference this one. And then the principal is this. But I want the principal to be referencing this payment and this interest. Oh, what did I miss? Payment amount. So this is interest. This is payment. Oh, there's no fees. We don't need this. No fees. No fees. Okay. So where's our payment at? Take this principal. And then, let's see, we already know that works, so let's just do this minus that. I thought I did that before. So if this equals first, come on. First, then choose this, otherwise 0. And then plus this. I swear I did that before. So there's your payment. Here's your interest. Oh, sorry, I had to sneeze. Here's your interest. Now this needs to be based on this now. And the principal is now based on this. This interest and this payment. And actually, we don't want to do this. We just want to. So here's how we're going to fix this amortization schedule to work like we want it. We're just going to do that minus that. And now the principal is just going to be, we're not going to care about anything. We're just going to do the previous principal minus the principal paid. And then interest. Yep. Let's see, this has got to come over here. Now we're cooking with gas here. So this works. Now theoretically, this should be less than this. True. All right. So we're paying less interest now. Perfect. So here's our balance. Let's just drag this down and see it. Now it should stop. Well, it's still stopping at month 60. Let's make this a bit more and see what happens. Let's say it's 2,000 extra. Just gotta see if the math is working. Okay, yeah, so see this negative means we need to stop. So Now this will have to be a rough number, but it's still pretty close. I mean, you're saying if basically if it's negative, if this whole thing is less than 0 or equal to 0, then blank. Otherwise, do it. So there, we stop here. Now we should be able to say if this equals blank, then blank, otherwise that. Now we stop that. Let's do the principal. If this equals blank, then blank. This is going to tell you at what time you can then switch over your payment. If O12 equals blank, then blank. Okay, there we go. So we're going to say this now saves us if we put an extra $2,000 a month on the principal. We paid it back in a couple months earlier, 4 months earlier, and we paid the total interest paid. Let's do new interest paid. New, we'll put a rate by this. So here's your total interest. New interest payment is going to be the sum of this. So savings, interest savings, and we could go ahead and move this down here. So we just saved $17,000 in interest. You paid it back sooner as well. So happy day. Now, how do we move to the next loan is the question. So we'll have to say let's also adjust the payment here. If O12 there we go. So these are actually what the new result is. And now we can apply our extra 2,000 to March 23rd of the next ranked loan. So here's the first. Now we know this is the first. The question is, what was the end date of the first? I guess we could do actually, hold on a second. This balance actually goes to the negative 12,000. We want to set this, if Q minus 12 is less than or equal to 0. No, if it's 0, it's okay. If it's less than 0, then blank. Otherwise, do it. And now we'll set O. Can just do if Q12 equals blank, then blank. Q here. Q. Q. We still got a circular reference here. All right, so if we do it like this, oh, I didn't drag it down. Okay, if I do it like that, we have errors here because, oh wait, that should be okay. We could do if error, so otherwise 0. I'll just head that way. So, let's do blank. It's blank if there is an error or it's less than 0. So this technically, you're saying after this payment, your balance is 15. You're going to make an overpayment here if you keep paying 28,000. So we just want to pay the remaining, but the key is the interest. That's all we really care about. So let's back this up. Let's just keep it like it was. Undo. Yeah, that's fine. So this is negative, it's fine, because really all we're trying to say is what are we saving in interest, and obviously the amount of interest you're saving. It's not really about cash flow. It's with the payment, like when that happens, is more about the interest savings. So we're saying as soon as this goes negative, it means this must have been negative and therefore you should have stopped paying it. So we could just keep the same logic if that works. So we're still saving. We saved 8,000 in interest. Now the question is we need to move this date into the second, which could be any one of these. And now we're actually going to have to just reduplicate number 3. Because 1 and 2 are now so out of date that I can't even use them. So this is going to be 1 and 2. And this will be 1, 2. Okay, so loan 3, we know it's the start one because it's that. Now payoff date is if this equals blank, if and the bottom one equals blank, and this is greater than 0, then it must be the last month. So the next one should go to the next loan. So if this is true, choose that, otherwise blank. And this will be do a short date just to see it. Actually, I better save this. All right. Excel templates. Loan payback optimization. That's fine. We can just pick the minimum there. So, and this. No, that's not going to work. It has to be the max. And this needs to be blank. N69 is blank, and N68 is not blank. There we go. Now we'll just get 1. Perfect. And you can see there's our end date. So this is a start date for loan 2 for, no, we can't put that there. Dang it. We have to do, well, let's see. We know whatever's in this position has to be the first one. So we could just do end date. Oh, this will work. End date equals, we'll do another indirect. But here, man, this video is going to be really long. We'll do indirect that. And then we're going to do max. And max of, what are we maxing? R. And there's our date. So we got the date, end date. So now we know rank 2 has to be this. And then end date here can just be that. Same logic is going to apply. And then this, same logic. And then we can work our way down, and that might be the answer. And then this final, this extra balance that's going to be on each of the loans is going to show what you end up paying. And I can clean all that up. I'll clean up all these boxes later. I just want to get this to work. All right, so we got to get loan. So we know loan number 1. We basically need 3 checks. We need to say, actually we need 12 checks. So if we're going to have 12 loans, right now we just need 3, but when we do all the loans, we'll need 12. So we'll have to say if that's first, here's the second, let's just do it this way. So let's say we know this is the order. 3, and we'll just do these 3 for now. Loan rank. And here we go, is if this equals that, then do it. So if this equals this, give me the date. We'll keep doing this down the line. And there we go. And now we can just apply this to S2. Dang it. See, every time I make a change, I got to make a copy and restart. So copy, copy, delete these. And let's go with 2, 1. Okay, so these all got it. So it's basically saying, oh wait, let's change this to loan 1, this to loan 2. So now we're saying, okay, loan 2, rank H6. Right, we don't know that yet because we haven't done the logic for this. So we've got the date here, fine. For this one, we know the rest of these are not going to match it, obviously. But when we go to 2, we say, okay, this is the one that, what's the second one? Loan 1, just so we could do this. So loan 1, we know matches it, so we need to start here. And we want to be paying the normal amount, so we want to say if the date we're on here is greater than or equal to this date, then do if this minus our extra payment amount. Otherwise, simply do that. Now let's see how that, oh, I gotta lock it here, so we'll lock V is the only one we need locked. Now this should start to go down on July 2023 if it's even still there. It's not even. So this will be paid back. This will be paid back before it's the other one is, so that's fine. Just put if errors around these. And you can see if I were to change this to be loan 3. Oh, now what happened? Oh, is loan 1 the max? If I were to change this to be loan 1, and this should be loan 1, then it should be the same. Now why is this NA? Oh, right. So if it's equal then or greater than or equal to V4, then do that much. Okay. Okay, wait. So problem here, we don't know what position. So let's do if error this otherwise blank. So here's our date. And we want to check that's always going to be a max of here. So that's the date we're checking in every single one. Oh no. So this has got the old logic in it. So we want to say, look, if this what are we saying here? Oh, what are we even saying here? So if I'm gonna pause the video because this is just gonna take hours. Stand by. Okay, I was able to clear my head and we got it figured out now. Um, so I had an extra column in there, M, that was not supposed to be, and I restructured some of this. So I think it's working. I think I can scale it out now. You can see, basically it just looks at the rank of the given loan on the given tab. So you can see there's number 2 is the third, this is the second, this is the first. So what it's doing is it's saying, okay, if you're the first ranked one, we know this is rank 1 position. If here's the start date, which is automatically equal to um, the rank H4, because we know this has to be the loan assumption start date here, and rank 1 has to start on that. We know that for sure. Now, as we go down, we can just simply make the next start month for the given loan, the second rank one, to be the end date of the previous one. So it ends here, this one starts here. So check it out. We have the second ranked one saying, okay, it knows it's the second ranked one, and it knows that means March 23rd is when it should adjust. Here's the problem. It's actually done on the 21st, so this never takes into effect. It just does the same payment schedule. You can see it ends when it was supposed to, so you just pay that like normal, no difference. However, since the second one ends on the 21st, so you could think of it like this: you're paying the third one back for a while, all the way to 2023. You're putting the extra $2,000 a month there because it's 2,000. Now, you can't apply that anywhere else before March of 2023. So now if we go to our last loan, now there's our issue. So that's our last thing to figure out. We need to make sure if the next one in line actually is not affected, we need to choose the start date of the previous end. And so we can say, let's see, how can we work that logic? So let's see what happens, what's something we could check for. So on the second one, on the first one here, there's no effect. So we want this date. Let's see, do we have 36 here? Yeah. So we can do if count ifs this. We'll have to do if and. So if and hold on. So only do this if this is greater than 0. If this is greater than 0, we know this is the end month. Then count ifs this is greater than 0. And so we got 36. So if the result of that equals this times this, we know nothing happened. So then we simply go to the last one. So we go Vlookup this minus 1, so the previous rank. Let's see, does that work? How do I get the previous rank? Oh, that's it. So now we just do Vlookup. We don't have to do this minus 1. Just Vlookup this and go here like this. So here is the actual end, and we have to drag that all the way down. Vlookup needs to be locked. This needs to be locked. That needs to be locked. Let's do a 1 here. Let's do a not blank. Okay, there we go. So if that is not blank, then do this. Otherwise blank. Lots of blanks here, but there we go. And now we actually want to count well, let's put S on these 3. So that's actually going to be one where it is early, so it's going to take let's see. So this is one where we actually want this date to come through. So if this is whole thing equals the date, if not, then choose that. How does that work? There we go. Okay, so now let's try that. There we go. And let's see, did this work? There we go. So now if we go to our ranking, we start here and here. Now we just need to look up max of S rather than R. And watch how this works. There we go. Now look, we have, so we know our second one actually this is over. So no changes here. You save $1 in savings. That's just because of this logic here with the interest. Basically no savings. The third one, however, this loan, there we go. It starts on March of 23rd. That's when we want it to start. It's the third loan. So now we're paying more and we're starting to save interest because now we paid it back that much earlier. How much did we save? Well, an extra $2,000 a month saved us 12 or 16,000. Now that's cool. And now we have all the logic. So all I have to do is duplicate this 12 times. So let's do, oh my goodness, I can't believe we got this to work. Now, well, the time will really be when I start actually doing a review with you guys, and we'll see truly if everything makes sense, but I think it's good to go. Making copies, copy. We got 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12. Okay, so here's 3. Rename this to 4, 5, 6, 7, 8, 9, 10, 11, 12. Now let's put money in all these. I'm really curious to see how this will work. Oh, where did I stick my where did I stick payment amount? Ah, there it is. So now that should be for all of these, right? Yeah, so S3 is the initial payment amount. There we go. There's the initial payment amount on all of these. And we need to adjust, so this is loan 1, 2, loan 3, but now we need to adjust, so this is going to be loan 4, loan 5. Oh, already see an error. We'll see why in a second. Loan 6, loan 7, 8. Probably because we need to adjust our tables with the new tabs to make sure it's all mapped. Oh, 10. 11 and 12. Okay, so why are we getting an error? Oh, we are ranking algorithm. So this needs to go down to 15, not 6. There we go, there's that. This is this. Now here we're going to set the rank 1 through 12. Look at that. this down, and we're cooking with gas. Right. So we got an error here still because loan 4. So what's going on with loan 4? It's a 9th ranked. We've got errors. Oh, shoot. This needs to be drugged down. Oh, man. No. Okay, so shoot. I didn't make it over far enough either. So everyone, I got to drag this over to you, and this needs to be drugged down. 2, 3, for all the way. 10, 11, 12. Okay, so we just got to drag it over to you, which all of these have to be done now. Drag it over to you. Drag it down to, how far did we go? To 14. 14. Okay, and we can't mess up any of the references, so we have to do this one by one. And I'm telling you right now, I knew this was going to be a challenge, but if we can get this working, I think it'll be worth it in the end. Oh, that's not what I wanted. 14. Okay. Here we go. Here we go. Go this down to 14. And then after this, I'm going to have to adjust all the Vlookups, but that'll be quicker. 14. We already did number 4. Let's do number 5. I literally have no other way to do this. I wish I did. Down to 14. Or 7. Now the thing with this is, you're actually, I mean, it's making some assumptions. Oh, what the heck? You're assuming that number one, you're paying the same, your extra payment amount is going to be the same, and you're assuming that you're you're going to reduce the loan that owes the most interest first, and then cycle through all the loans until, well, basically they're all paid off. And you can only allocate that extra amount if the loan that you start are currently on is all the way empty. So that's the key, is we're going to check and make sure this does that automatically. And here's a huge takeaway from this. And if you're still listening, I applaud you. Here's a huge takeaway from this. You will be able to see how much extra money you need to put per month, and that will tell you how fast you actually end up finishing paying off everything. Now, one adjustment that might be super useful is if I make a customization so that you can actually pick the extra amount of money you want to put on the loans over time instead of just being a fixed amount. But I just, at the moment, I don't know. I think right now it might just be the most feasible to have it be a fixed amount, and you could see, okay, well, I know I can save about this much every year. Based on that, how long it's going to take to do all this. All right, so this has to come down and reference all of these. I don't think anything else did a VLOOKUP, so let's just copy N now, starting with this. And we'll see what happens here. Now one of these should work, and then it should trigger the rest of them to work. That one we already know. Oh, that was probably the one. It was the fourth one that makes sense because we hadn't done anything past 4. And here's this. Okay, what? Oh, son of a gun. We still got an error. And the current, oh, now we got to adjust this too. The current payment is in U now, not S. So why do we still have an error? I do not know. Let's make this more, make all these more than a couple of years. Oh, geez, and these are really long. Let's just make this nothing over 30. Okay. So we've still got an error in our 4th ranked number. And that's resulting in an error in the rest of these. So here it is, and here's our error. Because there was another VLOOKUP in column S. Son of a gun. So we need to also adjust this so it goes all the way down, which should then fix the rest of this. So make S all the way down. So there we go, number 1. Number 2. That's what we did. 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now let's pray that that worked. Hey, now there we go. So this is basically saying you're going to get stuck on loan 11 and you'll be paying that off through the whole rest of these, because that doesn't end till 2045. So you can look here, what's loan 11? Well, it's 500,000 at 1%. So an extra $2,000 a month is just, by the time it gets to number 11, you can see here on February of 2043, because it's taking that long to get to the rest of these, we're now at 2043, and there's our extra payment. You can see it dynamically went from 1608 to 3608. That comes down to 2045. Now the thing is, I bet you that means all the rest of the loans, as you're paying, are already paid off. Now here's the next level I'm going to take this to. So let's do a monthly summary, and we're going to say the first date is our first date we're going to start paying. Actually, it'll be the current month. And then we'll go e-date 1, and we'll go date. And we'll go all the way out to 2000, and we're going to have to go really, you know what? Let's go downwards actually. It's actually a lot easier to go down. So we'll go down instead of over because we got too many dates or times to check. And we'll go all the way down for, let's say, 100 years. Sometime around there. So 70, 2070. Oh my goodness, I don't even want to think about that time. I will probably, well, I'd be 100 years old, so I'll be dead. Okay, so here's on a lighter note. So here's the month. Here's the we're gonna do loan one. So these will have to go across. Just note you're gonna have to keep the loans categorized from 1 through 12. You're going to have to keep this 1, 2, 3, 4 all the way to 12. So this cannot change. So let's put this in a different color. Now you could, to better keep track, you could put a description here, ID. So like AB, AC, AF, whatever. I'll just do L4 going down. But this can be changed if you just want to see, and then we can use that for other lookups. So you can actually have a descriptive term, but this cannot change. This 1 through 12 has to say 1 through 12. We'll put a comment on that too. Never change column B. You can change these though. Okay, so our monthly summary is going to be pretty cool, I think. So what we'll do is we'll have to do an indirect VLOOKUP and figure out what the debt service was per month for each loan. And this will give you a nice summary of your debt service. And then we can also do a, you know, we'll do a debt service modified debt service. And actually we'll put these at the front because there's going to be too much room. So we'll do modified debt service and then original debt service, assuming nothing. So you can compare them, or you could set this to 0 and it'd give you the same numbers as long as I did all the math right. So this is going to be modified. And then the next one's going to be original. And I should be able to do a lookup on, so I want to look up the date. So I want to VLOOKUP in column J. So look up sheet 1, get column J to N, the payment. And that's it. So let's see. Let's see if we can do the same. See if we do a VLOOKUP. Instead of a sum, does that work? So we want to VLOOKUP F2. Lock it down. We don't want it going down. And we want to look up J to N only. Now, if you want to get more complex, you could do the interest and principal, but we'll also show another column here that says, total interest saved. So here's your VLOOKUP. I don't know how this is going to work. VLOOKUP, we're actually looking up this date. Our table is indirect. And then J, K, L, M, and 5. I really don't know if this is going to work. No, it did not work. So we're looking up C3 and that range of that sheet. Right. How do we do an indirect VLOOKUP here? And you can see as you do these Excel models, you'll notice the formulas are obviously one part of just knowing what's possible, but the other part is actually figuring out how to fit everything together so you can actually make it do what you need. All right. Okay, so there's the syntax. So VLOOKUP. Now that actually looks about like what I've got it. So the question is, why isn't it working? This looks like what I've got. VLOOKUP, that, parenthesis, oh, no parenthesis here. And then in that case, there's none here at all. Oh wait, no numbers either. Hey, we got it. Now, the beauty of doing that, oh, C3 needs to be locked, is instead of trying to figure out how to map each formula to each tab, we can just drag this down. Just putting placeholders here so this will drag. And there we go. And you can see all the schedules. And there are all the schedules. So, I mean, we could do some things here like totals, total paid, and we could sum up this down to, how far does it go? Down to 756. Total paid. Let's lock this here, freeze it. We'll customize this to read out like the loan number. There's that. So total paid, we can make that top and double darker. And original is going to be the same formula. Just copy this here. Except for now we're looking up. Oh no. We have to go to our helpers. So we actually go, is this the payment? Yes, that's perfect. So we look up J and K. And only go over 2. And you can see, now this payment, whichever, what one was number 1? Loan 7. So let's go down to loan 7 here. See if we can really see the difference happen. Now what is, so that should be less. Loan 7 is number 1. It should start in August. Oh, duh. Because this is doing the original. So if we went over here, we can see, oh, look at the, oh, that's weird. So why it's starting at 45? Oh, what's going on? Now it's saving $1 million, but why? Oh, right. It should go up. The payment should go up. That's right. That's right. So it's saying, July we haven't started payments yet, but we're going to start in August. Let's say we change this to be, oh, what happened to my date? Oh, we had an error. Okay, that's okay. Let's see. We could just do can we do this? I highly doubt you'd start anytime before like that amount of periods, so that should be fine. Let's say we put this to September. So now you can see, boom, your payment for loan 7, it doesn't actually change till this month. And then these will all be the same until this is paid off, or these get paid off in the meantime. So you can see, you scroll down. Okay. Now look at what happens. This is paid off in September 39. Now the next highest amount of interest is this loan 10. You start paying that off. That gets paid off. Now the loan 11 gets the most, and that goes. All right, it works. Freaking I mean, I've been thinking about like, oh, this logic is really impossible. I don't think we'll ever be able to figure it out. But it, right there, it's done. That does what we want. It has enough value. I'm definitely going to put this model up for sale. You just saw me build it from complete scratch. That's good stuff. Stressful, but we figured it out, so that's good. So here's what we do is we say the modified debt service is this amount. Total paid is this amount. Try and make a nice summary to show you exactly what happens. Currency. So we'll spruce this up. What else can we do? We can do cumulative saved. And that'll be that would be modified minus this. And actually, let's drag this up. So why is that negative? Let's see. Oh, that's not going to be cumulative saved. But yeah, it is, because you're actually, you're actually paying. So let's do it this way. Do this minus this. So this is saying you're not paying anything different. Now you're actually paying 2,000 more, but it's paying off because if you go down, look at this. Now you're paying that much less because you paid off that loan early. So all this principal you're saving until they're all paid off. So you're actually saving a total of 1.53. Now if we go over here to our summary, we could do current payment amount, total interest saved, and look at this. We just do, it's going to be an indirect, and where's the interest saved? We have it in here as F3, or no, G3. So we'll do, oh, got the phone call, guys. 1 second. 1 second. Okay, are we back here? Yep. All right, so I just want to, we'll do some charts and stuff. I just want to make sure that this is accurate or it makes sense. And I don't even know how we go about checking it. The key is we just need to make sure we know it's going, it's like almost artificial intelligence here. We know it's going from top to bottom and checking each loan. And if it's paid off, it just goes back to the date of the previously paid off one. So here we could obviously see loan 10, it never gets past loan 10. So loan 11,312, let's check those. Let's go like 11 should be 0. So 11, oh wait, 11's got something there. All right, let's see what just happened. Loan 11. So the question is, why is this getting paid off early? So it's starting to be paid off in April of 2039. Oh, right. Yeah, that makes sense. So everything after loan 11 should not be. I was looking at the 5-1 here, and they're both 5-1, but this is 2043, so that's fine. So loan 312, let's see, 312. These are all not touched. That's good. Um, we also have then 84596. So 8, yep, 4, yep, 5, yep, 6. What was the last? That was it, 96. So those, perfect. Perfect. So we don't really need this, but I'm going to keep this here. You can kind of reference it if you're just trying to work through the model. But this is basically the rank. Don't need this information to be structured. This is really where your table starts at right here. So there's the rank, the loan number, interSode, start month, and helper. The monthly summary is going to be the coolest. And this is, so I've verified that does work. You can basically change this to anything and it will spit out an answer. Now what we could do is go to visuals, and what's a cool, let's see what it looks like to chart some of this. All right, so let's see, we got the month, going down to this. So here's where you might want to modify it yourself, because with Google Sheets, it will not chart blank stuff, but Excel will. So I'm just going to go to the last one here, down to row 243. So on your chart, just make sure you're going to have to go in and modify this based on when your last loan ends. Actually, I got to go down further. It's actually ending in at row 301. Now I will convert this to Google Sheets because there's no problem doing that with the formulas, but it's going to take time. So if you do buy this template, it's going to be $45 one-time fee. You'll also gain access to the Google Sheet version, and just go ahead and just request it, and I'll send it over. Okay. Now what in the world did I do? This needs to go down to 307, 301. There's that. And then this needs to be cumulative saved. And I want that to be that. Let's see what this chart looks like. Ah, now the question, so we save a lot. Now why is it going up and then down? Let's see. This is actually saved per month. If we want to do cumulative saved, we want to say it's simply the sum of this column going down. So sum of this, and just lock one of the letters or numbers, and there you go. So it'll be F. So there's saved per month. Make this a different, what color looks good? actually. I think it was pretty good how it was. Let's put this axis down low. Minus 30, and also put it lower because we got negatives in the mix. We need something that shows a negative a bit better. Yeah. Let's see. Doesn't make sense to do a line. Nah, that's fine. So there's your saved per month. And then we'll do cumulative saved. This is all interest or this is saying you're saving interest, but then that results in the being paid back sooner. So you're actually, this is just comparing the total payments per month. And so if you pay something off sooner, that starts to kick in. But see, you're paying more here, so you're paying $2,000 extra dollars a month here. So you're just saving less. But in the long run, you're saving on interest, and you pay that loan back. And as soon as that loan gets paid back sooner, you could see the first loan there gets paid back, and now you're starting to actually pay less debt service. And that's how, so you pay this upfront amount, and then it's all savings from there. So this is a really cool calculator. This is really cool. So we'll do cumulative saved is, what is that in column F? Do F and F. There we go. So you actually end up spending about $231,000 more, but then look at this. You get to 2035, you're back to break even, but you have all those loans paid back, and now look, you actually end up saving 513,000, which should be the total interest. So 635. Let's go to this. Is that really? Let's see. So this 635, does this make sense is the question. Let's see. So your total interest was that. It's now this. Let's go to one that you saved on actually. Number 11. We know we did there. So let's see. So this is what you would have paid. This is what you've now paid. You know what? This actually, that doesn't make sense. So we need to adjust this to total paid back, new paid back, total saved. Yeah, that doesn't make sense. We have to do it like this. And this will be total paid back is just sum of. We already know what that is. So this is just going to be the sum of principal, or the sum of the payment in N. And now this will be this minus this, 3,000. Now let's just copy that over to each one of these in F. Okay, that makes sense. That makes sense. Right, keep going. Whoa, 500,000 saved on that one. Is that the highest one? Yeah, loan 7 is the first. Now let's see. I mean, let's just look at that. Does that make sense? Our payment goes up here, but we now, because we're paying it back that much more, we're saving a ton of interest. And now we basically are done paying off that balance here, and we save. We now don't have to pay all of this. Is that right? Payment. Yep, that makes sense because this is actually higher. So this is $7.99, but you paid a little bit back more up top, so the net difference is $5.55. Man, that's crazy to see these kind of actual numbers played out. Very interesting. Now there will be like a small rounding error between like $1 and $10, but that's not going to be material in the scope of this, the benefit here. So now let's go to total saved. Oh, we got to change this again. So it's going to be G5. Okay, on each of the ones. There it is. So now that should match 626. And then if we go to our monthly summary, 626 saved. And then now here, now why is this 513? The only thing I could think. See, is this going all the way down? Yep. So you're saved. Wait a second. Cumulative F. So there must be a charting issue. Well, it's a good thing I caught that anyway, but that's the issue with the ranges on the chart. So here, this starts at F4. Okay, that's fine. This needs to start at F4 then. Or I mean B4, not B2. And now we should get our number. Oh, it's going to 513. So why is it stop? Oh, that's why, because we've stopped at 513, but really we're still saving because these are still going on. So son of a gun, we need to drop this down. This actually is going to go all the way to 363. So let's do 363 here. Peer reviewing myself here, 363. And this needs to be starting at B4. Because that starts at B4, E4, yep. So there's that. Now let's change this one. What did I say, 363? And 363. Now we're talking. And 626 is our number. That makes sense. So we've got our cumulative saves. You can see you're actually putting more cash out here. That's how much cash extra you put out. But then now look over the long haul. You look at the whole time. You end up saving all of that money. So you put more out, a little bit more out now, and you save a lot in the future by paying down, putting extra on. Now look, if you put this at 0, now these should theoretically be all the same. Oh, we got some errors. Probably, yeah. So if you put 0 here, you're just gonna get it. It basically means you're doing the same thing. There's a small adjustment here because we must be adding something, but that's not material. Let's say we put in $1. There we go. So if we put in $1, we're actually not saving any money. Now, why is that? Well, we're, oh shoot, what did I just do? You put in $1, we end up actually spending an extra 1,200 because my guess is we're actually not paying anything back all the way. So let's put in like 500, and now it says we're saving some, still saving about 250,000, but we're not totally paid back, I don't think, because these are still negatives here. And you could see our monthly or negative. So this is negative because why? The original is 1608 and we're paying 2108. But oh, here's why. Okay, so yeah, so we're paying a little bit, but then we're saving this much as the original keeps going. We've already paid it back, so we're done. So why is this still a net negative in 11 and 12? It must, okay, so here's why these are negative. It's because the other loans did get paid back, before these could start getting paid back. So you paid more on it, but towards the end of the loan. So you've actually um you're paying it back quicker, but you paid back more in the net. You didn't save as much interest as you paid on it, but you're still ending earlier. Let's see if we can do a total savings of time. So let's see, how do we do this? So we do count ifs this is blank. And as soon as that's 12, you can see here, as soon as that gets to 12, that means you're all paid back. So here we go. If countifs equals 12, we'll do an and in there too. So if this equals 12 and the above countifs is less than 12, then that's your payoff month. Then you want this month, otherwise blank. So it should be blank until the payoff. Okay, now why didn't that work? This needs to be 3. So if that equals 12 in the third one, now let's try. So payoff date original is, there we go, short dated 7/1/48, and your payoff date modified is the same formula, except we want to test the first 12. You see all the different things you could do with this here. And this should be sooner. Yeah, there it is. So you actually save money and you're paying it back sooner. So now we could do this. We could say, now this is our main summary, so let's just put it here. Where do we want to put this? Yeah, we'll put it here. So we could say original payoff date, modified payoff date. And this will just be max of that. And this is same deal, but it'll be F. And so you save yourself $516 without mortgage. So 516 days. So that's a nice chart there. Now look, you can say, let's put this to 2000 and see what it looks like. Oh, there you save yourself 1800 days, 600,000. Let's save 1200 extra dollars. Save yourself 1100 days, 483,000. At the end of the day, this is interest savings basically, because you're paying back the same principal. It's just you're not paying back so much interest. All right. Well, I think that's about all I got. Let's see, just make sure. Let's say we zero some of these out. Make sure this works just fine. It should be fine. Zero some of these out. And that's fine. If error, we just do a blank there. If error. So you're still currently paying 24. Wow, 1,200 a month. You're actually saving yourself 4,000 days. You saved a lot of interest there. Not as much there, but this negative just means, okay, you're starting to pay it back earlier, so you're still saving time. You're paying back the same amount, but you're doing it sooner. And it's negative there because you've started paying it back later. So in the total loan, you've actually lost 4,000. But at the end of the day, all you're doing is just paying extra principal back, right? So let's look. So this is loan 3. So here's your payment. So you're doing 8. This is the same, and then it starts to change here at 9,000. It's going. How much is it? 1,200 bucks extra. So based on that interest rate, it's only a 3% interest rate, which means you pay back more. So it's done now. You've still paid back a total of 459,000. And so it's a 459. So you paid back more principal, but $5,000 less interest. Now, we're going to see how the heck does that make sense? Because, let's see, this is less. We might need to change this to less than 0. It looks like is because we're doing this extra payment even though there's $24 of interest left. Okay, so this is negative save the same. You're basically overpaying. So the balance is at 139 and you're doing a whole nother payment. So we need to solve for that because that's actually a pretty big, that's a pretty big amount difference. So we want this payment, this will be tough. Payment. Okay, so here's what we got to do. We got to add, oh man, I don't got time to finish this. So if the balance is less than the payment amount, then make the payment the balance. Otherwise, do that. Oh, what happened? If this is less than this, plus that, then do that. Otherwise, okay. Let's go down here and try and do it on the actual one. So we want to do it basically here. So if you see this amount is greater, this is less. So if this whole thing is less than this, then this. Otherwise, do this whole thing. Now, does that work? Circular reference. So we need to solve this. I'm gonna have to come back to this tonight. Oh, dang, I don't want to leave this thing paused for 4 hours. Got to solve this right now. I want to do maybe we do if this minus that. No, that won't work. These amortization schedules are so difficult when you get into the nitty gritty here. So we just wanted to check that month. We need some clever way to make this payment amount just be this balance amount. And this all relies on the payment. We can't reference that. We have to reference the previous balance. So if this payment amount is greater than this, then this. Otherwise, do this whole thing. See if that worked. Yeah, that worked. What if we go up? Yes. Okay, so that worked. Oh, I got no time. Go down. There we go. Now, why is this a value error? Why is n giving me an error? We'll just do if error, no problem. If error, do this. we go. Oh, now what? Okay. There we go. So now we're actually saving the right amount. That works. Now the end, now here's the issue is the end. So this needs to be blank. Because this is the last month, not down here. Let's just check if n equals 0. Does that work? No. This is the last payment month. If n 63, 64 is not blank, and if n 65 equals 0, I'll shoot. Oh wait, this has to move up one. So I just want to say if this is greater than 0 and this equals 0. If n64 is greater than 0 and n65 equals 0. Oh, dang it. N65 equals 0. N64 greater. Okay, so what does this equal? This equals 0. Oh, it doesn't equal 0. Okay, so we'll do less than 0.1. If it is less than 0.9. Hey, there we go. Dang it. All right, we need this to not be 0. We need it to be blank. Don't know how. With this logic. Oh, man. All right, how do we do this? If and 2 above equals blank, but 1 above is not blank, then this, otherwise blank. I don't know if that's going to work. If oh, that did not work. Okay. We'll have to do zeros here. And we'll just have to take the max or the min of it. Min of R. So min of R or min of S. Oh, what is going on? All right, guys, I'm gonna have to pause this and come back. I hate doing this. I hate when I have to, can't finish it. min of S of S12 to S1000, right? That won't work. That won't work. All right, how am I going to do this? The point is, we need to make sure. Okay, so it was this one we were working on. So if this is less than 0.1, then 0. If this is less than 0.1, then blank. Let's see if that works. Now we need to go to our old formula with this R and S. There we go. Less than, maybe it'll change it to 1. Okay, that gets us up to the 23rd. So all we got to do is reference one more, because really it's the 22nd. Okay, that fixes that. And this is our date. I mean, really, we actually want to pick up the date ahead. Let's see how that works out. You know what? We'll keep it right on that date because it could be a big principal amount. So we know at least it'll be down below 1. So there's not going to be a difference if we choose that date. All right. So that's fine. I got to go now. I'll save this. I'm going to pause the video. If it ends, I'll have to do a follow-up video to show how I finished doing the visuals and the rankings and everything. But there you can see, yeah, now we got no negatives. That makes sense. I'm glad I fixed that. So I'll have to fix that. What was that number? Number 3? Yeah, so number 3, I just need to copy N to S to all the rest of the tabs. And it should be good to go. All right, guys. I'll see you back here in about 4 hours. All right, guys. Thankfully, the computer did not turn off. We're still recording here, so it's now 6:40 p.m. on June 24th, same day. And I just, for the sake of you guys not having to look through this or watch me, I pasted the right formula, so now we don't have any issues where there's a ton of principal being paid on the last month, like overpayment. It'll be within a couple dollars, which is fine. That's perfect. Before it was going and doing the entire, even if there was say $7 left, it was doing an entire um, payment of say do 9,000 here rather than the 1,100 or the 7. But now it pares it down once this amount gets lower than this, and it works. So that's great. Um, Really excited about this model. I think it's super helpful for a lot of people. Anybody basically has multiple loans and wants to try and pay them off sooner. This, obviously you could say, okay, I'm just gonna take the loan with the highest interest, pay it off with, put extra money towards it, and then when that one's paid off, I'll go to the next highest and so on. That's fine, but it's really hard in your head to figure out, well, how much money are you actually saving and what does your cash flow look like um, over time, which you can see here. And you can see the modified version. So this is if you're paying the extra amount on the principal, and this is if you're just doing the original principal and interest of the start of the loan. And the difference of those is how much you actually save and the time. We also measure the time here, so you can see we've saved 5,500 days by doing this. So that's nice. You pay more sooner, but uh, it goes way quicker. Now, this is another final additional feature I did is you can actually pick if you want to pay by the highest rate first. Now, that will not work if you have two rates that are the same. It just the ranking algorithm will not work. So you can only do that if all of your interest rates are different. If you don't want to do that, you can do the most total interest, which is how we did originally. And you can see the numbers just change there. And you can actually toggle them to see, well, if you put um, most total interest, you're saving 38,000, and that's basically saying instead of picking the loan with the highest rate, you pick the loan that's basically the biggest, so that has the most total interest over the life of it compared to all the others, um, starting at the current moment. And so that you can see saves 38,000 and 5,100 days. Going by the highest rate, you save only 3,400, but you pay it off and you save 5,500 days. So you're paying it off sooner if you go with the higher rate, but you're actually saving less money by $4,000. So that's an interesting feature that I just added that I think it might help. So other than that, this is clean. It's ready to go. Uh, you can see our visuals here. It says accumulative saved. So you can see how much extra you're paying here, but then you break even here, and you're actually starting to. This is your interest you're saving, and this is the monthly effect. And this is the monthly summary. You can see basically your cash flow every month, the total amount you're paying on each loan, modified versus original. This is original, and I think the main breakthrough here was the fact that I figured out you have to actually keep the original amortization schedule, but then use that in combination with the modified schedule, and then that all works with the ranking logic and the dates when one ends and it rolls over. It's all automated. So that is really awesome. If you guys want to purchase the model, go ahead, go to Smart Helping, or go to the description box below. It'll take you to the smarthelping.com page that has the model for download. Once you purchase it, I'll send it to you, and that's it. All right, guys. Well, hopefully you lasted this long, and now you see how I built this thing from scratch today. You have a great one.